Hi folks, and welcome back to Math with Captain Rod here, making this to be kind of video 2 here about logarithms. So in your notes here for this class, let's see, it says, what is a logarithm? Well, this actually should probably read logarithmic functions are the inverse of exponential functions. That's what they are. And one of the things you have to be able to do is go back and forth between logarithmic form and exponential form. And it's, it's kind of written right here, but I wrote another version over here, right? Logs have a certain base, so they're written like this. Log base A of B equals C. This is equivalent to A to the C equals B. I always think of the circle rule. A to the C equals B. And one of the things we want to be able to do is kind of go back and forth. So right here, if we have y equals 2 to the x, the base is 2, so this is equivalent to log base 2 of y equals x. Let's see, 2 to the x equals y. 2 to the x equals y, yep. This one right here, the base is 3, so this one is log base 3. Whoops. You write it smaller here for the base. Log, it's like a little subscript, base 3 of 2 equals y. Oops. Let's see. I got those backwards. Log base 3 of y equals 2. There we go. 3 squared equals y. Yep. Okay, this guy in logarithmic form. So what we're going to have is log base is 4 of 64 equals 3. Right, so 4 to the third equals 64. Yep. Right. Going back the other way, it's much more natural for me going the other way. Right. Just remember the circle rule. 5 to the x equals y. This one, 2 to the fourth equals y. This one, 5 to the x equals 125. So it's very important that you be able to go back and forth between from exponential form to logarithmic form, or from logarithmic form to exponential form. All right, there are some, let's see, in the notes here. Why do we teach logarithms and exponentials? Well, there's lots of reasons, but there's probably some specific ones here. So let's see, so solve for x. Well, there's, this one's pretty easy. I'm just going to write down the solution. 3 to the x equals 9. X has to be 2. This one also is pretty easy to solve. 3 to the third power is 27, so x is 3. And 3 to the fourth power is 81, so x is 4. Now, 3 to the x equals 50. One of the things we want to be able to do is figure out what x is, but you'll notice that 50 is not, it's not 3 to the third or 3 to the fourth or 3 to the fifth. What we can do is take a guess at it. We know that 3 to the third is 27 and 3 to the fourth is 81. So, this is somewhere between 3 and 4, maybe 3.4, 3.5, something like this. But I'll just write 3.4, and I'm just going to put G for a guess here with a question mark here. That's about all we can do with that for right now. All right, we're going to move on here. Okay. Write the exponential expression in logarithmic form. Do not solve. All right. So this one right here can be written log base 4 of 16 equals 2. And I always have to kind of check this going the other way. 4 squared equals 16. Yep. This one is log base 2 of 1 over 32 equals negative 5. And I always check it. 2 to the minus 5 equals 1/3. Yep. This one, I don't have my glasses on. I think that's x. So this one is log base q. Darn it. You should write these smaller. It's like a subscript. Log base q of p equals x. Q to the x equals p. Yep, that's good. This one, log base y. I did it again. It's like a little subscript here. Base, you should write it smaller. So y, or log base y of x equals t. And I always double check these. Y to the t equals x. Whoops, what happened to that? y to the t equals x. Okay, that's good. Moving on. Write the logarithm. Oh, I didn't type that. Write the logarithmic expression in exponential form. Do not solve. Okay, so this one is 3 to the 0 equals 1. This one is 5 to the x equals 25. Okay, ln x. So there's lots of different bases. Two of the most common bases for logarithms are log base 10. Log base 10 of x usually is just written log of x. If you don't see a base written, it's assumed to be 10. Another common one is what's called the natural exponential number, which is sometimes called e, which is 2.7 something, goes on forever. I'll be making other videos about where that one comes from. This ln means log base e. So this means e to the y equals x. Okay. This one means x to the 1/2 equals 9. All right, now it says to evaluate. Let's go ahead and start taking a look at these. Now when it says evaluate, it means, what are these things equal to? I'm going to go ahead and, let's say this is equal to x, and then write it in exponential form. This means 10 to the x equals 10. Well, x has to be 1. This one means, and again I'm going to say let's call this equal to x, and this means 3 to the x equals 9. So x has to be 2. And I'll keep going on the left here. This is some number, let's call it x, and this means 5 to the x equals 125. So x has to be 3. 5 squared is 25 times 3 more is 125. All right, this is equal to some number x, and this means in exponential form 10 to the x equals 100. So x is 2. This is equal to some number x. This means 9 to the x equals 1. So x has to be 0. Anything to the 0 is 1. Other than 0 to the 0, that's called indeterminate. All right, log with nothing written. If it's not written, it's assumed to be 10. So I'm going to put equals x. And this means 10 to the x equals this number. 1, 2, 3, 1. Yep. So x has to be negative 4. All right, special logarithms, or write as logarithms here. All right. So this is log base e of 0.1353 equals negative 2. I always want to check this. E to the minus 2 equals this number. You can also just write this natural log, or ln of 0.1353 equals negative 2. That's perfectly acceptable. Natural log is log base e. Again, where the e is 2.7, goes on and on and on, and I'll talk more about what that is in other videos here. Let's see, write as a logarithm. So this one is log base 10 of 2 equals 1.301. Yep. Common log means log base 10. All right. So let's see, it says, in short, natural log is written as ln. I'll put ln x here. Common log is written, common log means base 10. That's usually written log x or log n or log something. And I think what I'll do is stop this video right here, because I've got to go find myself a calculator here to finish this up. And besides, the video is getting plenty long here. Again, this is just kind of a mid video here, getting some of your notes done on logarithms. I'll be back. Have a great day.